Welcome to section 3.5. It's a little bit different than the previous sections. There's going to be actually no truth tables in here. They're just going to have us analyze arguments first using what's called Euler diagrams. And Euler diagrams are basically circles where you kind of see where the overlaps are. So I'll try to give you some examples, and then there's really no need to turn to the homework for this because the homework would just be very, very similar in terms of I'm actually grabbing these problems from the homework, but there's no need to physically see that. So this should be the only video for this 3.5 section. So let me give you an example. They're going to do what they call an argument, and they'll do the same thing in 3.6, but in 3.6 we're going to use truth tables. But let me give you a first example. So for that first example, I'm going to write this. You'll see something like this. All amusement parks have thrill rides. Universal Studios is an amusement park. And then they'll put this line. Sorry about my lame handwriting. So then it will say Universal Studios has thrill rides. And they want to know whether this is a valid argument or not. And so the answers are valid or invalid, but you want to substantiate them. So the way that Euler did his justifications is very visual. It's very nice. And so I think this section is going to go very well. So all amusement parks have thrill rides. So what does that mean? Let's draw a picture of that. So all amusement parks have thrill rides. So we have thrill rides as a big circle here. So I'll put thrill rides. And all amusement parks will fit into that. So hopefully you can read my handwriting okay. Maybe I'll type the next one out, but you're going to create these basically circles. And sometimes the circles will be inside one another. Sometimes they won't. And so, but in this case, if I'm going to properly diagram this out, we have this large category of thrill rides. And inside that thrill rides are every single amusement park because all amusement parks have them. Now, from the second statement, we learned, so all that came from the first statement. From the second statement right here, we learned that Universal Studios, and let me come in here with an X, is an amusement park. So that's where it lives. It lives in the land of amusement parks. And the end statement is, that means Universal Studio has thrill rides. Absolutely it has thrill rides because it's within the thrill ride circle. So you would write as an answer to this, this is valid because that X is part of the thrill rides. Okay. I just mentioned I might type the next one out. Let's see if I can do that. Okay, so the next one that I'm seeing is this. Let me make that a little bit bigger. I can make that bigger if I call it let me go to a title. Sorry about that. All celebrities have problems. That man has problems. Go again, put it as that man has problems. And then let me stop there so I can get a line underneath that because I don't think I can have that line go under there. So they have this line then. So all celebrities have problems. That man has problems. And so the conclusion we're making is that man is a celebrity. Okay. So can we make that conclusion? Is that a valid argument? So as you go to do this, it says, hey, all celebrities have problems. So what's the big circle? So back here, all amusement parks have thrill rides. So the big circle right here is, hey, these are people with problems. Okay, these people, so I'll put have problems. However you want to denote that, because it's very visual. So that man, and then within this bubble, we have another circle. It doesn't have to be right in the middle, but typically they are. We have celebrities. So what do we know about this man? So what we have drawn out right here is from the very first statement that all celebrities have problems. Now we're going to go put an X for the man that has the problem. Now where can that X go? And the question is does it have to go in celebrities? Do you agree the man could be here? The man doesn't necessarily have to be a celebrity to have problems. He could be in the have problems area, but not be a celebrity. So they'll say that this is invalid because that X does not have to be in celebrities. Up here, that X had to be in amusement parks and therefore needed to be in thrill rides, so it was valid. And so you're going to go through and look at each one of those. Let's look at something else here. What about this? All residents, sorry about my lame handwriting. Try to write better. All residents of Colorado know how to breathe in thin air. Okay, I'm going to switch colors here. I'm going to try to make the colors in here. Julie lives in Colorado. And so the conclusion is Julie knows how to breathe in thin air. So if I use my pen for that blue statement, what do we know? We know we're going to have a big circle and some kind of little circle in the middle. So what's the big circle? Is the big circle Colorado or breathing in thin air? And it's actually the breathe in thin air. And what we have here in the middle is, I'll keep it in blue, is Colorado. Colorado, you know how to breathe in thin air, right? Other places too, you would know how to breathe in thin air, right? If we lived in Nepal, which has Mount Everest as part of it, we would know how to breathe in thin air. So there's other things within this breathe in thin air thing. We're just focused on Colorado. Now, what do we know about Julie? Well, that's the red thing. What we know about Julie is that she lives in Colorado. She's part of this circle. Is she then guaranteed to be in the breathe in thin air? Yes. So it's a valid argument. And we're moving on to the next one, right? And so that's what we're doing each time as we go in here. Let me do just a few more, and hopefully this will help each time. So how about this one? All drivers must have photo ID. K has a photo ID. Therefore, K is a driver. Is that a valid argument? And what we hear a lot of times, very much invalid arguments being used, implications that just aren't true, especially in politics, right? If we listen long enough, we can definitely find one. So what do we have from the blue? Who's our big circle? Well, our big circle actually is photo ID. And what we know are the drivers all must be issued licenses, and therefore they have photo ID. Now, what about K? Can we imply that, switch to red, can we imply that K has, or K is a driver? Well, we know K has a photo ID, but it doesn't necessarily have to be in the driver one. It could be out here, right? So let's put it where it could be. She could have a school ID. She could have some kind of photo ID for work and may not drive to work, right? And so therefore, she would have a photo ID but not be a driver. So this is an invalid argument. And you're doing this all with pictures. That's pretty much the whole assignment as you go through. Now, does it get crazy? Potentially. Let's look at something like this. Let's look at this next wording. The next wording says, some philosophers are absent-minded. Nicole is a philosopher. Therefore, that's what that line means. Nicole is absent-minded. So you could take a look at this on your own, right? Hey, some philosophers are absent-minded, but not all of them. So just because Nicole is a philosopher doesn't mean she's absent-minded, invalid. They do want you to draw pictures, though. So what we have are two groups, absent-minded. Now, they're not saying that all philosophers are absent-minded, but there is some intersection. So here's my philosophers. And here's that overlap right here where we have the absent-minded philosophers, and it may be even a greater overlap than that. We just need a picture. Now, where's Nicole? Does Nicole have to be in that cross-section and be absent-minded? No, she could be out here. So this is invalid. So this was what it's going to look like if some. Notice these were all directly inside because they used the word all, right? All. And so we had to put them inside. Oops. Didn't mean to do that. So that's what we're looking at there. Now let's go to some later problems and just make sure that we're going to do okay. So in some of these ones, you want to just draw a picture of what's going on and with little circles. So let's look at this one. Amarillo is northeast of Roswell. Amarillo is northeast of El Paso. Therefore, Roswell must be or is northeast of El Paso. And so we want to just look through the argument and see, does that have to be the case? So let's go ahead and let's put in Roswell. Here's Roswell. I'll just put Ros. I'll put a circle around it. Now Amarillo is northeast of that. So let me put Amarillo somewhere northeast. So here's Amarillo. So that's a true statement right now. Amarillo is northeast of Roswell. Well, where can El Paso be? What we know is Amarillo is northeast of El Paso. So the question is, does El Paso have to be out here? If it is out here, if this is El Paso, then definitely Roswell is northeast of that. But did it have to be there? Not necessarily. We have no idea without a map about the relationship. And if I put El Paso right there, what if I didn't put it here? It could be there, but it also could be here, and every statement would be true. Amarillo is still northeast of El Paso. And El Paso is not northeast of Roswell. We wouldn't know that for sure, right? So just knowing that Amarillo is northeast of Roswell and Amarillo is northeast of El Paso, Roswell does not have to be northeast of El Paso. So this is invalid. Invalid because we could draw it in a position where it is not northeast. Now it's southeast, right? Or I apologize, it's northwest. Roswell is northwest of El Paso, right? And I could have put it maybe even up here, and then it would have been southwest of El Paso, and then have Amarillo still ahead. So with some of these, you're just going to draw pictures and see what happens. What about something like this? No whole numbers are negative. Let me just start with that first statement. How are we going to draw that? No whole numbers are negative. So here's my whole numbers. And what if I don't want any of them to be negative? What if I don't want my negatives to be associated? Well, then I just draw my negatives out here. There's my negatives. None of them are whole numbers. Perfect. That's how you draw that. -3 is a negative number. Well, they just put is negative. Okay, that's true. So let me put that in red. Get my pen back here. Here's -3 as part of the negatives. And so what are they going to conclude off of that? Therefore, -3 is not a whole number. Well, that's true. It's not part of the whole number, so this is a valid argument, right? And so sometimes I just want you to see what happens if they're disjoint from one another, if they're not part of it. I want you to see one where there were some overlap, and also ones where you're really just positioning things based upon like a description of where they're laid out. But this is what the homework's like, and I think it will go pretty quickly. It's intuitive, and it's not using the truth tables. We'll do that in 3.6. So just a way to evaluate arguments, but very standard in there. So this will be the only video for 3.5 and should